Thanks very much for the opportunity to speak, and thanks for that last presentation. It's really interesting research. So, I'm just going to be presenting on the health benefits and cost savings of sugar and sugar drinks taxes in New Zealand on behalf of myself and my co-authors listed there. So I'm just going to start with the main messages of the presentation. So a sugar drinks tax is modelled to generate modest health gains and cost savings to the health system. So it's about 140,000 dollars and 2.2 billion cost savings to the health system. A sugar tax is modelled to generate really large health gains and cost savings, 2.6 million dollars, and $37 billion in cost savings. Both of these interventions could contribute to a reduction in ethnic health inequities. So these results are over the life course of those that were alive in 2011. That's how we do the modelling. They are undiscounted, so we value future gains in the same way as current gains. And these savings are in addition to the revenue that we gain from the actual tax. So now that I've given you my main messages, I just wanted to go through how we came up with these numbers and give you some more detailed results. So the sugar tax that I'm presenting is based on a paper. I put the citation up here. The levels are based on a 20% fruit and vegetable subsidy, so we calculated the expected change in expenditure for a 20% fruit and vegetable subsidy, and that would decrease the cost of the average diet by 3.4%, and then we matched the taxes to that decrease. So the sugar tax we're presenting on, the 72 cents per 100 grams of sugar would increase the cost of the average diet by 3.4%. So if you implement both of those at the same time, you expect no change in the cost of diet. The sugar drinks tax wasn't part of this paper, so I just modelled that separately using the same methods, but it isn't matched to the 3.4% change in expenditure. So one of the key parts of the method is price elasticities. So these show the change in demand based on the change in price. They come from a relatively recent virtual supermarket project that was carried out in New Zealand. And we broke down into own price elasticities, which show the change in demand for the product that is having the price change. So in this example, we changed the price of chicken, and the own price elasticity is the change in the purchasing and consumption of chicken. Cross price elasticities, you change the price of chicken, and it's the change in purchasing and consumption of other foods, breads, fruit, etc. So in the model, the tax changes the price, and then the price elasticities change the purchasing and therefore consumption of the foods, and this gives us the change in dietary risk factors of the model. So we're looking at the sugar tax that I mentioned, and two sugar sweetened, sorry I'm saying sugar sweetened all the time, sugary drinks taxes. So we've got sugar sweetened soft drinks and energy drinks is the kind of more simple tax. And then we've got a wider definition, which is sugar sweetened soft drinks, energy drinks, fruit drinks, and sports drinks. And also that fruit and vegetable subsidy that I mentioned. So these change the intake of fruit and vegetables and sugary drinks, as well as intake of sodium, polyunsaturated fat intake, and the change in BMI for a change in energy intake, which are the risk factors we use in this particular model. So then we move into the multi-state life table model, which combines this change in risk factor with relative risks from the global burden of disease into what we call population impact fractions, which impact the disease incidence, which gives us a change in mortality and morbidity rates, which we then use to calculate the change in quality adjusted life years and health system costs. In the model we have those dietary risk factors that I mentioned and 17 diseases that are related to diet. We've got cardiovascular disease, type 2 diabetes, osteoarthritis, and 13 different cancers. As I mentioned at the beginning, this models the people that were alive in 2011 over their life course. It takes a health systems perspective, and there's no discounting, so we're valuing future health gain the same as current health gain. We produce the quality adjusted life years, net health system cost savings in this case, and age standardised quality adjusted life year gain for Māori and non-Māori, which is expressed as a ratio, so you can see whether health gain is high for Māori or non-Māori. Okay, so the first set of results, this is the health gain, the quality adjusted life years, per 1,000 population. So you can see that the sugar tax gives the greatest health gain for a single intervention at 581 quality adjusted life years per 1,000 population over the life course of the people alive in 2011. And it's even greater when you combine it with the fruit and vegetable subsidy. You can see that the sugary drinks taxes give quite a lot less health gain at 10 per 1,000 population and 31 per 1,000 population for that wider definition. And when you combine them with a fruit and vegetable subsidy, that increases as well. The health savings, health system cost savings. So all these interventions are cost saving, so they'll save health system money if they're implemented. Again, the biggest gains is for the sugar tax, and when combined with the fruit and vegetable subsidy, you get $9,400 saved per person alive in 2011 over their life course. And again, the sugar drinks tax give less cost savings, but keep in mind that in a number of health interventions, you're having to work out how much the government would be willing to pay in order to save a quality adjusted life year. So working out the cost effectiveness of the intervention, and all these taxes are cost saving, so that's a real positive to start with. This is the ratio of health gain between Māori and non-Māori. You can see that red line here is at 1, where health gains are the same between Māori and non-Māori. All the taxes give greater health gains to Māori. Almost twice as many health gains per person for the sugar tax, and almost 3 times as many health gains for the most simple sugary drinks tax. The fruit and vegetable subsidy is not particularly appropriate. So these are just the results for the whole population. I've been presenting per capita results. So I'll just highlight a few messages here. So the sugar tax gives really high health savings, 2.6 million qualities and 37 billion cost savings to the health system, and again that's on top of the income generated from the tax. The sugary drinks tax also give health gain and cost savings, and they're more likely to be pro-equity. Considering the number of countries around the world that are implementing sugary drinks taxes, the fact that you get health gain and cost savings, and it should be pro-equity if it's implemented properly, there's really strong justification for implementing a sugary drinks tax in New Zealand. If politicians wanted to make it more desirable from the public's perspective, you could combine it with a fruit and vegetable subsidy, which would give larger overall gains. It would probably decrease the cost of the average diet, but it's not as positive for reducing health inequities. So just the conclusions from this piece of research. Sugar tax would generate large health gains and cost savings to the health system if implemented in New Zealand. A much more politically feasible sugary drinks tax would generate modest health gains and cost savings to the health system. And if you tax a wider range of sugary drinks, you'll get greater gains. Sugar and especially sugary drinks taxes have the potential to reduce economic health inequities if implemented